Hey guys, welcome back. So let's continue learning about the data structure trie. And today we will see its implementation, which is very important because you can be directly asked to either implement trie in any interview, or you can be given a dictionary like problems which will be majorly solved by just implementing the trie data structure. You just have to figure out that it's asking for a trie data structure. All right, so I will do and explain the code of trie implementation in steps. So here is the basic class that we create. So as you can see, we have a class node here, which has a constructor function in it. And we are basically creating a map of self.children and is word equal to false. So this map self.children will basically store all of the children of a particular node. So suppose you have a root node C and you have different like A or T here. Then this self.children for C will store A and T. So basically storing all of the children. There can be more. So basically self.children will store all of the children for a particular node. Alright. And is word equal to false means that suppose at A, the property is word is false. That means that CA is not a word. But then you have another node CAR and is word is true here. So is word is true here. We will mark is word equal to true whenever we know that this is a word. So this means that you have found a word in the subtree CAR, which is car. Alright. And this is the class for trie. So we will basically be starting with a root node, taking the node class to make a node for root. All right, this is very basic. Let's move on and let's see how we will insert. Whenever we are inserting, we have a loop. As you can see here, we are provided with the word. Suppose we have to include a word car. Let's take the example car. So for each character in word, each W in word, we'll basically check if the W if it does not exist in the node.children. So we have this map of children for like each node. And we start from the root node and we check if that W, it does not exist. If it does not exist, then we create a W. So we will create a node for C and then point the node to the node's children. So if it does not exist, we will basically create a new node. So C here and then point our node to C. And this will continue for each character of the word given. So now we will come to A. We will see that it does not exist in the particular node's children, in C's children. So we will add a new node and point to it. And similarly, the last one we will do for R. And at the end, the most important part, we will mark node dot is word property equal to true. This will be is word, which will simply signify that car is a word. All right, let's move on and see how we will search for a node. So suppose you are given search for a word. So suppose you are given a trie data structure, something like CAR and S and T here. All right, and you have to search for a word CAR, and this property is marked that is word true. This property is also marked that is word true, and this property is also marked that is word true. All right, you have to search for a word car. You have to return if it exists or not, true or false. Okay, so here also we will check for each character in the word. So W in word, we will check if it does not exist in the children, because suppose C, if it does not exist, then we will simply return false. Or if in the next one, suppose C exists and then A does not exist, then we simply return false. But if this condition is false, which means we come to the next statement, node equal to node.children W, which means we will mark our node, we will point our node from C to A and then from A to R. And this will run for all of the characters in word. So first C, it comes to node.children, then it comes to A, then it comes to R. And our word has ended. We come out of the loop, we come to this line, return node.isWord. So we will check if CAR at R, this node, if isWord is marked as true or false. If it is marked as true, then we will simply return true. If it is not marked as true, which is it is marked as false, that means we will return false. Alright, this is how the search runs in trie. And now moving on to the last implementation is checking if there is a subword. So suppose like our previous example, you have cars and then you have cat and then suppose CS, something like that. But like now only CAT is marked as word and CARS is marked as word. Not car is not marked as word. Or suppose car is also marked as this word and we are given the prefix CA. So we have to check if CA exists or not, if there's a word that starts with CA or not. All right, now we will again, like previous ones, we will run this for loop, W in prefix. So for each character in prefix, for C, we will check if it does not exist, because if C does not exist, then we will simply return false. This is very, very similar to the search implementation. And then we will move to the next node and then to the next node. The only difference from search and starts with is the last statement. We simply return true. As soon as we come out of the loop, we know that we have checked for C and then A, which means we will come out of the loop and we will return true, which means the prefix exists. As you must have seen in the search, we had to return only when the isword criteria is true. But here we do not check for it because we are only checking for the prefix. So CA means it is true. All right, that is the major difference between starts with and search. And I hope you got to understand a little bit about the try implementation. I will be compiling the code and giving it to you as a solution so you can practice it and get a better understanding of it. Please let me know if you have any questions. Thank you for watching, everyone.